Welcome to my video. For my final year design project, I have designed a flow meter for the measurement of biogas coming from an anaerobic digester, which is seen on the left. The flow meter is on the right. Anaerobic digestion is the breakdown of organic material by bacteria to form biogas. Biogas generally consists of 60% methane and 40% carbon dioxide. It can be upgraded and pumped back into the gas pipeline. It can be used to generate electricity, which can then be sold back into the national grid. It can also be used for vehicle transport fuel. As we zoom in here on the left on the anaerobic digester, we see a condenser. The two pipes protruding from the cylinder will be connected to a controller. This controls the temperature of the anaerobic digester process. In front of us now we see a nitrogen flusher. This will ensure that there's anaerobic conditions before anaerobic digestion starts to take place. Here we see an input hot water pipe and an output water pipe, again for temperature control. As this is a continuous stirred tank reactor or CSTR, there is a motor with a shaft which propels paddles at the bottom, continuously stirring the organic material. In reality, there is 8 paddles. 2 paddles can be seen here. As the camera spins around, we look up and we see the exhaust pipe of the gas. This is at the top of the digester. The gas exits here and travels along this pipe. It enters the tank and goes up into the tip bucket flow meter, which is submerged in water. As the biogas enters, it is forced into the cavity that we can clearly see here. The gas will eventually build up to a level which will cause the bucket to tip as the bucket pivots on the axis seen on the right. The bucket will tip from left to right, and the gas will start gathering again on the right, and the bucket will tip back from right to left, and this continuously happens. Here we can see a resting block to prevent over-rotation of the tip bucket. It also holds the bucket in place until such enough gas has been produced to make sure the bucket will tip fully over. Here is another magnet which travels along the path, the axis here as shown, the path of rotation I should say as shown, and will pass a copper wire generating a current. This current passes down the green wire as seen and to a computer. Each time the bucket tips, the computer will record it. As can be seen, the wire is not submerged in the water for obvious reasons and is covered at all times by a plastic tube. Finally, the gas released into the headspace as the bucket tips will come out this yellow pipe and into our storage bags, seen in red. Storage bags come in many different shapes and sizes, can be made to order, and are relatively cheap. They are the ideal way of storing gas. Everything, as you have seen, is to scale, bar possibly the pipes themselves will have a smaller diameter in reality. Thank you for taking the time to watch the video. I hope this has clarified anything that was previously unclear.